everyone. Happy to be here to discuss about innovation solutions to reduce time and cost of fiber cable deployment. Maybe the first question is, as many often we speak about innovations, but why do we have to always innovate? What are the reasons behind? The world is in multiple transitions. One of them being the digitization. So we all know that, and the figures were presented yesterday, that there is a plan to bring fiber to all European citizens by 2030. If we look at the gigabytes that everyone is downloaded every month, you see in this first graph that in Western countries, so far today, we download roughly 200 gigabytes per month per household. If we figure out what will be this amount of data within only 5 years, it will be multiplied by 5. So there is a need for more data at home. In this trend, there is another revolution, which is the artificial intelligence. So we all know this is a big revolution that will change our lives. So this is also a trend that we need to follow. Another trend is sustainability. It was also mentioned a lot of time during those days. So Europe also has a plan. We need to be neutral by 2050. There is a few already regulations ongoing, CSRD being one of them. So meaning that companies will start to report their own carbon footprint of their own organization. So we know that when we look at the carbon emission of the digital, it represents roughly 4% of the worldwide emissions. So given like this, it's not that high, but it's growing very fast, between 6 and 8% a year. So we need as well to tackle these issues. And actually, those two trends are already are also connected, because the digital has a potential to decrease by 15% the carbon emission of the global industry. And on our side, we know that fiber is the greenest technology to manage this. And if you have downloaded the white paper that we just released yesterday, we've done a study at the Council, and we try to assess the carbon emission of the fiber industry and to see whether what was the weight compared to the industry in Europe. And it's only about 1% of the total emission of the industry, which is roughly 800 tons of CO2. So you see, fiber only 1%, but has this potential to make 15% savings. And third, I would like to talk about why do we need innovation. It's also because there is these interest rates which are growing very fast, and we have seen that above 2.5%, it has really a real impact on our business. So meaning that we still need to be creative and innovative to find solutions to decrease the cost of ownership of the rollout. And it goes more or less together, has this huge plan in many countries to make the rollout. There is a kind of shortage of labor. Sometimes also we need to train people. So this is all together what we need to have innovations to tackle all those challenges and unlock new possibilities. So my name is Xavier Renard. I'm at the board of the FTTH Council, and I'm also marketing director of AECOM Group. Just a few words. AECOM Group is a French industrial company specialized in high-tech cables, ducts, and connectivity. We are based in France. I have factories across Europe. We've been in the telecom sector for many years, more than 50 years. Obviously, at that time, it was not for fiber, but copper, but still more than 20 years in fiber. So today, we have on the stage Adrien Amescoa from Prysmian, Technical Sales Director. We have Peter Wieman, CTO, optical fiber cable business from HFCL. We have Tadeo Viana, EMEA VP Sales from Corning, and José Luis González, Regional Market Manager of Comscope. The innovation that will be shown today shall then demonstrate, first, improved total cost of ownership, productivity or time saving, or tackle this issue of labor shortage, and at the same time, to look at the sustainability issue, so having a longer lifetime and decrease the environmental impact. So first, Adrian, Prysmian is a global cabling solution provider linking the energy transition and digital transformation. Having a wide geographical footprint and a large product range and a solid customer base, Prysmian continues to develop resilient, high-performing, sustainable, and innovative cable solutions in the segments of transmission, power grid, electrification, and digital solution. With more than 100 factories in over 50 countries and 30,000 employees, Prysmian had sales of over 15 billion euros. So now, I welcome Adrien to tell us how Prysmian's solutions enables more efficiency in the rollout and how this is also addressing carbon footprint challenges.
Thank you, Xavier. Thank you, everyone, for joining. So the objective here is to show some ideas on how we can, with innovative optical fiber and optical cables, we can help our customers to reduce the installation cost and the total cost of ownership of the digital infrastructure, and also how it can make the optical fiber network more sustainable and less carbon emission. So, as Javier said, there is a need to increase capacity. Fiber optic is the backbone of all communications, and now there is a need to increase the capacity. And this is not going to slow, and it's not going to stop, and it's only going to continue growing. With AI, everyone talks about more capacity in the data center, more data centers, more energy consumption, but obviously there is need for more fiber. And this we see it in the last year, for example, if we look at the subsea part of the optical infrastructure, there has been a huge growth in fiber capacity. Some years ago, the most recent cable probably had only 8 to 12 fiber pairs. Today, the cables that are being deployed under the seabed, they have 16 to 24, so that's almost double. If we look at the long-haul network, today, the most highest capacity long-haul networks are being deployed with 288 or even 432, or even in some cases 864 fibers in the long haul. A few years ago, maybe 144, that was maximum. In the access network, Metro and Access, today there are some networks that are being deployed with up to 1728 fibers. So you see that in all the part of the optical infrastructure, there is a need to increase capacity. So we have to develop new ways to unlock all available space. That's the best way to reduce cost, if you can install the fiber with less civil works. Then we need to develop new cable solution, new fibers that enable high capacity, high fiber count cables. We need to be able to reduce the cost, reduce the resources, and reduce the installation time. And with that, we are able to reduce the environmental impact of the optical infrastructure. So a key enabler to achieve all these goals is first to develop bending-sensitive fibers. G65782 fibers were developed in 2006. Prysmian was actually the first one in launch G65782. Then in 2009, the reduced version, the 200 micron, was invented. With this, the diameter is 30% smaller, the area. And then in 2020, there is the 180 micron fiber that is 50% smaller, and with this we can achieve very high capacity, very high fiber count cables. That's the first step, to use reduced diameter, high quality with very good coatings and bending loss. The next step is to improve the material, use better materials in the tubes to be able to make smaller and more compact loose tubes, for example. If we go back to the 90s, the Optical cables probably look very similar. A loose tube cable, you have the central strain member and then the tubes stranded, but the tubes were big. Let's say 2.5 millimeter with 12 fibers. And then in the 2013, we have some cables with 200 micron fiber that can fit 24 fibers in 1.3 millimeter. And in 2020, with the invention of 100 micron bending sensitive fiber, we can make loose tube cables with diameter of 0.9 millimeter with 12 fibers and 1.1 with 24 fibers, for example. So you see that by doing this, it's possible to generate and create new cable solution that will be very compact and with very high fiber count. So there are today we'll talk about two types of cables that are quite innovative, will help to reduce the cost of the installation. It will help to increase the capacity of the network and obviously reduce the CO2. So first is a ribbon cable. These are flexible ribbons that can be bent. They can be very compact, and we can achieve very high fiber count cables. And the other type of cable is the microduct cables with a very, very tight loose tubes and with very high fiber count. So these two will help to reduce the time, increase the density, and reduce CO2. How do we do this? For example, if you look at a very high fiber count cable that can go from, let's say, 864 fiber up to 6912, if you want to splice single fiber, it will take a lot of time. It will take 864 fiber, probably it will take 30 to 40 hours to splice if it's loose tube. Single fiber. If it's a ribbon, it will probably take 30 hours. So there is 10 hours, sorry. So there is a significant reduction on the time of splicing. With this technology, you can see the ribbons are very flexible. They can be bent in all directions and can be spliced 12 fibers at the same time. So in this example, you can see they can be spliced in a very compact splicing closure. This is an 864 fiber cable that will help to reduce the splicing time from 35 hours to about 10 hours. So this is quite critical for data center interconnect infrastructure, that the repair time has to be very fast. If there is a break in the cable has to be up and running very fast. And this is one way to do it. So there is a reduction of cost, and very important, it's possible to offer very tight service level agreements in the contract for data center interconnect and metropolitan networks. Then, if we look to very high density cables, this is the highest density cables are the microduct cables. We have developed cables with 200 micron G65782 fiber. That can, for example, can fit 432 fibers in 10 millimeter microducts. So in 10 millimeter microducts, you can put 432 fibers that are installed by blowing very fast. And if you take a 7-way bundle, you can go up to 1728 fibers in a 30 millimeter microduct bundle. So you see that this type of cable will enable very high capacity and with a pay-as-you-grow model. So this type of cable will help to develop very high capacity networks that can be expanded with time and with reduced raw materials. So there is a benefit in the environmental footprint. Then if we go with 180 micron fiber, here the density can be even higher. And in this type of, with this type of fiber, we can develop cables that have 9.8 millimeter that can be installed in 12 millimeter microducts with up to 864 fibers. So with this, the demand of capacity, the demand of fiber can be achieved. We can follow the trend of AI, of new technologies that will come. But now, let's look at what we can do to reduce the carbon impact of the digital infrastructure. First of all, fiber is the most green technology for transmission of data. And what else can we do? So first, with innovative cables, innovative fibers, we can make cables that will consume less raw materials and that will consume less resources during the installation. So these are the two main aspects that will help to reduce the carbon footprint. For example, if we use new cable systems that are smaller, in this case, there is a customer of ours that was using 96 fibers in a cable of 6.5 millimeter. With the new fiber and the new cable type, they move to 4.5 millimeter, and very important, they move from 14 10 millimeter microducts to 10 7 millimeter microducts. So you see that it's 50% smaller microducts and smaller cables. So 50% less raw material, basically. Then, by using reclaimed materials in the microduct, there is a significant reduction of the carbon footprint of the microducts, and very important, there is the reduction of the logistic cost and the drums needed to transport the microducts. So more or less 60% less drums and logistic cost. If we look at the carbon footprint, with this technology, there is 40% less carbon emission verified by APDs. So it's very interesting to see that with an idea of reducing the cable, you can achieve a lot in terms of carbon emission. So this is one way to do it. And now, how else can we do to reduce the carbon emissions? So we look at the innovation of the fiber, we look at the innovation of the cable, we look at reducing the installation, the civil works, and the raw materials. But now, what happens if we extend the lifetime of the cable? So if we extend the lifetime of the cable, there is a less carbon footprint that is needed during the lifetime of the cable. And with this, by testing the fiber, by testing the cable, by testing the raw materials, and by improving the raw materials that are used in the coatings, for example, and in the plastics of the cable, we can achieve microduct cables that have a 50+ years lifetime. So this is a new announcement of Premium that we did during the conference. With our microduct cables, these cables can be deployed and can be at least in service for 50 years. And in combination with very high fiber count, then you are future-proofing your network. Finally, because we are in Germany, we have been talking about high-capacity, high-density networks, but fiber is also used in low-density cables, very big cables with very few fiber counts that are enabling the energy transformation of Germany. This is a very interesting project that is connecting the wind farms in the North Sea with all the cities in the south of Germany. It's a 400, 500 kilovolts cable that goes from the north to the south, and it has fiber to control the temperature and to optimize the transmission of energy. So fiber is quite important for digital infrastructure, but also for the green energy transformation of Europe. Thanks.
Thank you, Adrian. Now we'll welcome on stage Peter. So HFCL is a leading technology company specializing in creating digital networks for telcos, enterprises, and governments. Over 37 years, HFCL is offering innovative and sustainable high-tech solutions, including optical cable and connectivity, wireless solutions, and services. Now I welcome Peter to tell us how HFCL enables to speed up the rollout and minimize the labor requirements.
Thank you, Xavier, and good morning, everyone. My timing going after Adrian is perfect because we're talking about similar things. We're talking about the microcable revolution that's happened over 25 years in the industry. This chart is the result of about, an hour and a half of research I did one afternoon, looking at how microcable density has increased over the last 25 years with a lot of hard work by a lot of people throughout the industry. Fiber people, cable people, materials suppliers. And if I missed someone's contribution to the microcable evolution, I apologize, but this is what I found in my research. The first true microcable was William Griffion at Draka, published in 1999, and 48 fibers, 1.6 fibers per millimeter squared. Now, as I show an example of a cable I had a good picture of, was 8.2 fibers per millimeter squared that we introduced last year here at FTTH. And as Adrian noted, there's cables that have gone beyond that. How have we done it? The fiber technology itself has gotten better. Bend-insensitive fiber has been a big part of the story. Both the commodity-grade fiber has migrated from G652D to G657A1, which is an improvement over G652D that has a high mode field diameter. But we also have the more bend-insensitive fibers, either the low mode field diameter 657A1 or the A2 fibers, where changing the preform significantly gives you a more bend-insensitive fiber. The coating diameter has gone down over the years, and we're now down at 180. One thing to note, though, and this is mechanics and physics of fiber, the IEC has a technical report on glass and glass breaks, and one thing that does happen, the thinner the coating gets, the more likely the glass is to break during manufacture. That can translate into higher cost. Once the fiber makes it to the cable factory, it's great, it's fine. With these low coating diameter fibers, there's absolutely nothing to worry about mechanical reliability in the field. The headache is for the manufacturer. Once it goes through our screening process and makes it into cable, it's fine for 30 years, 50 years. I wouldn't be surprised if it was beyond 50 years with the materials. We just haven't had time to do the accelerated aging studies as an industry to qualify that. And the material suppliers have had a big part of that. Improved fiber coating technology, improved jacketing technology to make thin jackets, and the equipment manufacturers, cable production has gotten more precise, which is necessary to make these small tubes and small cables. There's lots of choices in microcable now. And what's the right microcable solution for any given network? One thing I always like to say is start at the end and work backwards. Think about the infrastructure and the labor that you're going to use to install the cable and your right-of-way. Start there and work back to what the right cable solution is. Do you have infrastructure available? Is there multipath microduct in the ground that you can access? You're always better off using existing infrastructure or adapting existing infrastructure than trying to build new. Even laying microduct is an expensive and time-consuming process. Where are you going? Are you in an urban area where you might have issues with permitting and access to streets, suburban or a rural area where construction is no big deal? And then also consider what's the labor skill and availability for installation, our fusion splicers and installation technicians available, and what do you need beyond the cable? Not just the duct, but the vaults, the closures, the cabinets, that kind of thing. Another thing to consider, we're here at FTTH, is what is the right, when considering the right microcable, is what's your split architecture? Are you using a centralized split or a distributed split? These have benefits and drawbacks. We're seeing more distributed split in the USA, where I live. Centralized split is a good choice if you're in a high-density area. It's lower electronics cost. It's easy repair because everything's happening at one central location at that single splitter cabinet out in the field. On the other hand, in centralized split, if you've got a remote cabinet, that's a big thing you have to place on a sidewalk or in a public right-of-way, and that's a concern. Sometimes cities and residents don't like having this big refrigerator-sized thing on their street. Distributed split, you put individual splitters at different locations throughout the network. The good news is that you can make everything smaller. Instead of cabinets, you might be able to put your splitter in a closure. And you can use a lower fiber count cable, which means you can use a smaller microduct, smaller vaults, smaller handholds. The system cost can come down. But it's potential higher electronics cost because you don't use your OLT ports as efficiently. And it's can be harder to maintain because if you have a problem in splitting, where is that problem? It's often more useful in medium to low density areas where the cable runs are long, and especially in places where you have a high expected take rate because of the way the ports get used. A third thing to consider is what's the right fiber count for your cable? There's different models of how to do it. Adrian referred to pay as you grow, where you get a microduct and you put in just the fiber you need now and you have empty microducts for future capacity. The advantage of that is that's going to be your lowest upfront cable cost. And again, if you can use a very small cable, which means everything else in your network can be small. On the other hand, if you need to upgrade and add capacity, It's a new installation. You're sending out a van, you're sending out a jetting machine, and the overall total cost of ownership might be more expensive to grow incrementally. Another option is maximum fiber now. Put the absolute highest fiber count you can put in that microduct, which might be something you'd want to do, say, for example, in Frankfurt, if there's one microduct available, you might want to put a 576 in there or an 864 in there. Adding fiber is relatively inexpensive. Fiber cable is typically about 7% of the cost of a typical installation. And you have your future capacity in the ground, maybe not lit yet, but ready to go. But it does result in higher upfront cable costs, and you might need larger vaults, enclosures, and other kit. And there's sort of balancing it in the middle. Add a little extra fiber and be ready to go for a future installation or future expansion without having to install new cable. And maybe you can use the less expensive G657A1 glass. So you don't absolutely maximize the microduct, but you don't go with the minimum fiber you need. It's not the least expensive, it's not the maximum flexibility, but it's a potential way to go. I have a couple of examples. Rather than talking about the whole product line, I'll talk about a couple of innovations that we put in place at HFCL recently. One thing that can save time, we've developed a low-friction microcable jacket. We have our own plastic compounding facility outside Bangalore, and our R&D team gave that group a challenge. Can you make us a low-friction jacket? Can you make us something that's different than what's out there on the market that could help these microcables do better? So after a bunch of trials, we came up with a material, and we did a torture test, something that was beyond what you would normally do in the field. We took a big cable with 250 micron fiber, and I calculated fill ratio by diameter to diameter, not area to area like Adrian. 85% fill ratio over what's recommended. We installed it on our installation track at our facility in Hyderabad. Higher fill than you would normally do, and did a head-to-head trial, same cable core, commercial jacket versus our low-friction material. And we were able to increase the jetting speed from 64 to 80 meters a minute and reduce the time to install that cable 2 kilometers, or 1,500, about 2 kilometers in this case, by about 5 minutes. For one cable, that's not much, but if you've got a long network to install, if you have a lot of cables to install, that adds up over time when labor cost is tight. Second thing we've done is we've developed what we call intermittently bonded ribbons. We are a company of engineers. We're not particularly good at marketing, so we're using the same name that the IEC is using for this technology. Others call it flex ribbon or other names, but we're using the generic name for it. And as Adrian referred to, this can save a lot of time splicing. Our application engineering team did a head-to-head study of the time to splice 12 fibers between a traditional microcable and these IBR ribbons. And it's about an 85% reduction in time for splicing 12 fibers. So if you consider a 432 8.2 millimeter microcable, about 12 hours to splice it. For a 1728, we can do it in almost about 60% of the time to splice 4 times the amount of fiber. The third time-saving example is putting these two technologies together: microcable technology, the low-friction cable technology, and the IBR. We did an R&D trial of a dummy cable with 12.2 millimeter central tube design in 1,000 meters of 2016 microduct. We did a torture test that required us to take left and right turns, or S and Z turns. The standard jacket could only go 600 meters. The low-friction jacket could make the whole route. So what we've done is we've developed central tube, very high-density IBR microcables, 250 micron, so it's backward compatible with the installed base. And these cables we've been able to demonstrate jetting of over 1 kilometer with all of them in relatively small microducts, a 576 that fits in a 2016, for example, and have been able to go these whole routes. There are advantages and disadvantages between the stranded loose tube microcable and the IBR type microcable. The stranded loose tube is always going to have higher packing density. The connectivity of the ribbons are going to limit how tightly we can pack them together. An example, for a 250 micron cable with 288 fibers, our loose tube microcable is 8.9, Our IBR microcable is 9.8. Jetting performance, a loose tube will generally do better than central core because the strength's in the middle, it's easier to push. And bending and handling the loose tube will generally be better. On the other hand, splicing and restoration time, that's where the ribbon shines. That's the advantage of the ribbon, is saving you time in splicing. The backward compatibility, some people are using 200 micron IBR. There's talk of 180 micron IBR, even 165 micron IBR out in the field. And when you splice that to the installed base, you have to do a pitch conversion, which takes a lot of time, where all these small fibers, they're compatible with 250, because when you strip the coating, everything's 125. Fiber management is a lot easier with the IBR. The ribbons behave wonderfully in a closure. And cost, it depends. What fiber are you using? What's the diameter of the cable? There are puts and takes there about what the cost difference is. To summarize, microcables are like hats. One size doesn't fit all. You need the right solution for your specific application. Things to consider, most important, what infrastructure is already in place for you to take advantage of. In the short term, think of your overall system cost and the speed of installation. What's your cost of civil works? What's your cost of your PON architecture? What installer and termination labor is available? And what's the overall cost of not just the cable, but all the other things you need, like vaults and closures and that sort of thing. Long-term system cost speed matters as well. Restoration is a problem. If you have a cut, how fast can you get service back up? Are you servicing 10 homes in a rural area, or are you serving Deutsche Bank? And then finally, presented a couple of time-saving innovations we've developed over the last year at HFCL, low-friction jacketing and intermittently bonded ribbon microcable. These are additional time-saving tools in the microcable toolbox that might fit an individual network's application. Thank you for your time and attention.
Thank you, Peter. So now we will welcome Tadeu. So Corning Optical Communications is part of Corning Incorporated and is known as the inventor of the first low-loss optical fiber over 50 years ago. Corning Optical Connectivity Solutions are delivering high-quality broadband capabilities across the enterprise, carrier, and wireless markets. With high demand for bandwidth, Corning is responding with innovations for fiber to the premises, wireless technology, in-building networks, and data centers. Tadeu, now you will tell us how Corning integrates in the factory part of field the complexity and helps solving the bottleneck of the qualified labor.
Thank you. Thank you, Xavier. Good morning, all. Very nice to have you all here. Perhaps what you're going to hear from me is not much different from the colleagues, but I think it's a good thing for all of you. Yeah. Basically, before I start talking about how we can build faster and simpler, let's set the context and understand the reasons behind it. Yeah. As Xavier said, the world is becoming digital, so there's a massive volume of data that's being transported on the networks. Yeah, we have some examples how that volume of data has been increased, in an exponential way. I think the pandemic is a very good one. Yeah, so all of a sudden we were stuck at home, and we needed to work from home. We needed to do shopping from home. So the volume of data that was transported on the networks was increasing significantly. Recently, we have the artificial intelligence become more and more, a known application. It's very widely used by everybody. And with that, what we have is not only a massive data being processed in the data centers, but that data needs to be moved among servers and from servers to users. Yeah, and it is clear, I think, for everybody that the copper is not the most convenient way to do it. We need the fiber. The question now is not whether we're going to move to fiber, but when and how fast we're going to move to fiber. Yeah, and then that creates some challenges to the operators, to the carriers. Yeah, because from the customer perspective, the faster the better. But the question is, okay, but me as a carrier, I face some challenges. Yeah, I have a limited capex. have limited OpEx, yeah? So they have this need of passing homes as fast as possible, but also they face some constraints, like for instance, skilled labor. So it's more and more difficult to find people that are trained in the deployment of fiber in the networks, because everybody's doing the same and everybody's using the same amount of people that are actually skilled on that, yeah? Limited space across all infrastructure. And why is that? Because we cannot get rid of the copper, and the copper is congesting the ducts and the poles, so we need to pass the fiber infrastructure at the same time that the copper infrastructure is already there. And we need to do this in a reliable way, and we need to do this without hurting the environment. So the copper network that is in place was built along 30 years without much concern about environment. But now, we know we need to do something about the environment. We feel that every day. When we go out home, we face, very challenging weather. So we need to build a network that's based on fiber, much faster than we did before with copper, and with a very important concern about reliability, yeah? That brings the sustainability topic. So that is the context, yeah? That's why we need to build networks fast, but we need to pay a lot of attention, to the constraints that we have, and we have to do it in a sustainable way. Then, I chose 4 topics that I believe that could actually help us addressing those constraints. So I'm going to speak in the next few minutes very briefly about these 4 topics. The first one we'll start with is the pre-connectorized. So how is that? We use more of pre-connectorized to replace the splicing that is done in the field, because we believe that splicing is one of the main constraints when it comes to skilled labor force. So more connectorizing you do your network, less people you need in the field that is actually skilled and that uses expensive tools. Then we're going to talk a little bit more about the cables and the terminals. How is that we put more fibers on the cables and make them bendable, because with that, we can actually manage the space in the ducts in a very efficient way. We can reduce not only the cable diameter, but also the hardware that comes with it. And then we're going to talk a little bit about simplicity, and what we mean by simplicity is how that you can actually build a network in a very simple way, not only deploying the network, but also designing that network and make it future ready. So when the next thing comes after, FTTH, could be 5G or 6G, you're able to expand that network without much work. And finally, we're going to share some data about sustainability. How is that we do all of that with a reduced carbon footprint? Starting by pre-connectorized technology. And you see some pictures illustrating one of those very small terminals that we sell today. Yeah? So we connect the users from there, and you see the way we connect the user today is not doing splicing, but to come with a very tiny, small form factor connector, and you just plug into the terminal. So the training that it takes for someone to do that's nearly none. So can actually, use a much broader a range of people, skilled people, than as if we do the splicing, yeah? And also, that people don't need to carry very heavy, expensive tools like splicing machines, because all of that is done, in the field without the need of expensive tools. So at the end of the day, what we're talking about, what is the idea that is behind it is the complexity that was normally done in the field, which is doing the fiber splicing, is being moved to the factory. So we don't do splicing at home because we came up with a technology that is done in the plants that helps you to reduce the number of splicing. And when you do that, you take the responsibility of doing the most complicated part of the work out of the field people, you move it to the plant. So we do it faster, we do it cheaper, we do it also more efficiently with a very small, near zero failure rate, yeah? Also, the networks that you build with that, they're not only, easier to do, easier to deploy, but also future ready in the sense that you can actually add more fiber to it. You can grow the architecture without much effort. Quality and reliability is also helpful, and of course, we're talking about a plug-and-play solution. But then, let me move to the next one, which is, how is that we make smaller things, smaller cable, and also smaller terminals. So what is the idea behind it, yeah? And that's actually very simple, which is, if you do fibers with a smaller diameter, though seems to be obvious that we can actually put more fibers in the same cable, yeah? So we are moving from the conventional 250 micro diameter from the fiber to smaller diameters, like 200 micro, or even better than that, 190 micro. When you do that, you can put more fibers on the same cable diameter, or, which is very useful, when we're talking about congested ducts, you can actually keep the same diameter, the one that feeds to the duct, but then, you put more fibers in it, yeah? Or do it smaller, because then if the duct is congested, the same number of fiber is going to fit in the cable with a smaller diameter, and that cable can actually pass the duct, yeah? So this is pretty obvious. But then that fiber needs not only to be smaller, but needs to be bendable. So we're actually talking about more bending-sensitive fibers, something that my colleagues have talked already, yeah? And what is the help with that? Because that fiber can bend more. Also, the hardware that comes with it becomes smaller. So I'm talking about smaller fiber closures, smaller terminals. And when we're talking about deploying in a congested infrastructure, occupied, very busy manholes or poles, if we're talking about overhead, that could be very, very useful, yeah? And let me talk also about the technology that was mentioned already by Adrian and Peter, which is the ribbon technology. And here in Europe, yeah, some people may say, well, that's not new, that's not a big innovation. Ribbon cables, they exist for a while, but there was a decision for most of the customers, most of the operators in Europe, not to use it. And I think infrastructure was created that was mostly based on loose tube, especially the splicing machines. They're prepared, to do one fiber. And at this moment, to do the investment to move to ribbon, though we all understand that ribbon adds more fibers per cable, might not be convenient, because then I need to invest in expensive splicing machines to do the splicing on ribbon cable. But then we have this innovative technology on ribbon that not only you have that solid ribbon, but you can actually detach or expand the ribbon. We call it the full ribbon technology. Our colleagues, they call it slightly different, but the idea behind it is pretty simple, is that to give flexibility to the ribbon, so you can splice it like a ribbon, but you can also splice fiber per fiber, so if you can actually reuse the splicing machines that you have in the field. So that flexibility makes ribbon a technology that certainly every operator in Europe should consider, as of today. Yeah, it's much easier to use than before. So we put it all together, smaller fibers, arranged in a different way in the cable, using flexible ribbon technology, flow ribbon technology, and bendable in a way that makes smaller terminals. And that is addressing one of the critical problems that we have today, which is deploying this in very limited space in very congested environment, yeah? Moving then to the third topic, which is reducing complexity, simplicity, yeah? The moment that you don't do splicing in the field, the moment that your network is made of segments with connectors on both ends, that are actually, assembling them like Lego pieces, that is much easier to deploy. And that is not only easy to deploy, that's easy also to design. So it's a simpler and easier process and a faster one since the very first moment you start designing your network, yeah? And that concept applies not only to the outside plant part of the network, but also on the inside plant. The more you connectorize, the less you splice. That means that you're actually doing your inside plant space more organized, more dense in terms of fiber. Then becomes again the importance of using, smaller diameter fibers, smaller connectors, because that increases the density on the inside plant space. And that then basically what happens is you need less and less space in our central offices, in a way that when you do the decommission of your copper network, the savings that you do on the real estate side, because you need much less central offices, the buildings itself, that money can actually be used to help you deploy the network. Yeah. So simplicity comes with the fact that you use pre-connectorized network, with the fact that you use small form factor connectors. So the ideas behind, they're pretty much the same. And the last, but not least by any means, we need to care about sustainability. And then I will reinforce the message from my previous colleagues. Yeah. First, let's talk about the carbon footprint reductions that you have, when you do, smaller diameter fibers. The simple fact that you take your fiber to 150 and don't make it to 150 anymore, like make it to 100, that per se brings a 17% reduction in carbon footprint. And then you do something on top of it, which is let's use as much as possible renewable ways of electricity. So let's not use electricity that comes from burning fuel, but let's use energy that comes from the air or from the sun. When you do that, the reduction of carbon footprint is quite significant, because one of the most important cost components from the fiber manufacturing is actually electricity. Yeah? And also, you have another gains, like smaller the cable, that means less of waste of plastic material, the jackets and so. So there's also counts when we're talking about using less material and reducing the carbon footprint. That's all about the product, but when the product is deployed, there's another advantage, which is if the cable is really small, so instead of putting that cable in deep, wide trenches, you can actually use micro trenching, which is a much more simple technology. You do a small trenching, you pass the cable on it, and then not only the carbon footprint is reduced, but also the disturbance on the environment of the user is much less, because it's much easier to do a small trenching than do a super big one. So life and the people actually is less affected, but the fact that we need to build that network without removing the copper network that was already there. Yeah. So all of this together, brings a lot of contribution, to the reduction of the carbon footprint. So those were the 4 topics that I wanted to share with you. What else could I tell here? Keep it local. And something that we learn, and I think most of the manufacturers, they learned the hard way, is that idea that we had before the pandemics of using very globalized, centralized supply chain, maybe their idea was not that good. Our planet has become more complicated in many ways. Not that we want it, but it's a fact we need to accept. So geopolitical factors, So transportation routes were affected first because of the pandemics, and then because of the war, and continues to be like that. We need to accept the fact that this is not going to change. It hasn't changed in the last 5 years. It has gone worse, actually. Yeah. So in terms of EMEA, our strategy as manufacturer, and I believe my colleagues will agree, is to make our supply chain as local as possible. So we're talking about making the fiber here, making the cable here, making the hardware connectivity here as well, in a way that we become independent of anything that could happen in the planet. Yeah. So we believe this to be very, very important as well. Last one, just a very short summary. Yeah. So the ideas are pretty much the same. I think, we did not disagree to anything that the previous colleague said about the way we do the products, yeah? But then, something that we can add to it, build with foresight. That means, at time of doing the planning, whatever is the provider that you choose, talk to your provider, provide him a decent forecast. Let's discuss this, because the more, we discuss about the needs from the users, the better your provider is going to serve you. Make cost efficiency a priority. So all that we said here actually helps a lot reducing the CapEx. And the CapEx has been very expensive these days with the high interest rates. And of course, if you do that, you're going to see your network being built in less time, with a lower cost, with more reliability, thanks to the innovations, to the ideas that we just discussed here. Yeah? So that's what I wanted to share. Thank you very much.
Thank you, Tadeu. And now I will welcome José Luis. So Comscope designs, manufactures, installs, and supports the hardware infrastructure and software intelligence that enables the digital society to interact and thrive. Together with their customers, Comscope advances broadband, enterprise, and wireless networks to power progress and create lasting connections, solving today's challenges with innovation that will meet the needs of what's next. So now I welcome José Luis to tell us how Comscope leverage the installation simplicity to de-skill and remove pressure on the labor shortage, and on how quality matters with concrete examples.
Thank you, Xavier. Good morning, everyone. I've been 26 years here, so I'm part of the furniture. So, and for the last, since 2008, 2009, my role has been very technical in many countries. Don't feel offense for some of the pictures that you will see that are from some of the countries, including mine, but many countries across Europe. My role has been mainly technical. So I'm what we call in Comscope a network architect. So normally, what we are going to do today in 15 minutes, I take 2 days with an operator. So, but okay, let's try to make, to give you some lessons learned over the last 16 years of fiber deployments in Europe, okay? So as I said, only 15 minutes, but let's go step by step. Just some key things. So obviously, everybody wants to build the network the fastest, the cheapest, but then you need to have a reliable network, okay? So you cannot build any type of network. What is the secret to make that? What are the lessons learned over the past 16, 70 years? The first one, make things simple. Don't make bricolage, okay? So if you remember, in the early days, everybody was thinking of using field connectors. After 15, 16 years, we sell field connectors. By the way, I'm not going to show Comscope products. We sell field connectors. I never recommend using field connectors, okay? That's one of the lessons learned. I've been failing in front of a big operator, making myself the connectors. So it's very technician dependent. Things like that. Don't make bricolage. An operator in Southern, very big operator in the Mediterranean area, they were putting boxes, and they were in the MDU area, and they were putting pigtails for the drop, pigtails for the main cable, and they were splicing everything, 2 splices for every single customer connection. Things like that are not simple. Now I have a customer in the Benelux area. They take 1 day to activate a customer. So over the years, we have learned a bit what works, what it does not work. Skill concentration, that's very important. Somebody said yesterday that in Germany, now they are lacking 6,000 splicers. In the UK, in the past 2-3 years, I've been working a lot there. The price per splice in the UK is 16, 17 pounds. That if you are the big operator, okay? And the problem is not the price only, it's the lack of people. Now all the Portuguese, all the Spanish, all the Romanians, we are all going to the UK to, make splices because it's profitable. But even that, there is not enough people. I work a lot also in Ireland. They have the same thing. They pay the splice at 20 euros. Even with that, they cannot get people enough. So you need to concentrate the skills. And like Tadeu, for instance, was saying, probably you should be using much more connectorization. If you think, for instance, in an MDU area, an indoor drop today, pre-connectorized, costs 5-6 euros. If you need to make 2 splices and the cable, probably it's 3 times. So make things simple. And then the type of products. The first networks in Europe were the Portuguese, the French, the Spanish networks. I have a customer in Portugal that is asking me if we can provide the covers for the boxes, because all the boxes on the walls, the covers are falling down. Obvious, because they were putting very simple boxes that you need to open every time you need to activate a customer. So over time, the boxes remain open, and the covers fall down. Same thing in Saudi Arabia. I was working a lot with STC, and same thing. The problem is that you are putting a box that can remain open in the middle of the desert. So probably it's not the best idea. So you want to go fast. Some tips from our experience on how you need to go fast. 2-3 years ago in the UK, everybody was rushing, all needed material. The incumbent was asking to some of our colleagues and to me, or not to me, to Comscope, they were asking 80,000 terminals a month. Huge amount. Can you imagine the other 150 alternative operators in the UK, how they were supplied? They were very little supplied. So you need to go to assure your supply chain and go for standardized products. You need to secure the manpower availability. That is key. You cannot go fast if you don't have the splicing people. Or most probably what you need to do is to reduce the splicing in the network, for instance, and the specialized labor. The German networks are very manpower consuming because everything is thick. And you probably cannot dig and cover more than 100 meters a day with a crew. So you need to make things simple. Then you have here in Germany the NVT cabinets, where everything is a splice. So you are making a very rigid network, in my view. It's a fantastic network, but it's very rigid. When you need to make changes, you will need to go with scissors and make the changes with scissors. So there are ways that over the years, not Comscope, all the suppliers and your integrators, we have all learned things that work and things that don't work. Okay, this is a big customer. This is with their numbers. When they were using, and they were doing till last year, an only a splice network, the time per home pass and the time to connect a home, making splices to connect the home, was obviously much higher than if you have pre-connectorized elements. Like, for instance, Tadeo was saying, if you can have pre-connectorized elements from the factory, that even they are cheaper than if you make it at home or if you make it, in your network, is very different. It's like if you go to IKEA, you buy the furniture, and you hire a technician to build the furniture in your house. Okay? You may go to the carpenter and buy the furniture ready. Okay? So, it's a big difference. And probably the furniture that you buy in the carpenter is going to be probably better quality, right? Simplicity. I have to be honest with you, my legal department didn't let me put all the pictures I wanted to put. And then I'm serious. That was the truth. For instance, the picture in the bottom, I had a nice picture from France. Okay, and no offense, again, but you can go to the cabinets in France. You can take any cabinet you want. There are 72,000 cabinets in France in the Zone 2 and Zone 3. And they are all with a very big, nice spaghetti waterfall there. Okay? And that is because it was a good idea, but now 4 operators access that cabinet. So 4 different types of crews access that cabinet to make patches. Imagine what it happens. The pictures on the left-hand side, the lane they put out, that one is Portugal, one of the first networks. If you go in Lisbon or in Porto or in any of the big cities, you will see many of those with the boxes open. Because when you have a box that you need to open to activate a home, the box will remain open. Again, no offense. Same thing in France. In France, to activate a customer, you need to make a splice in that box. So imagine what that brings. It brings time, but it brings probably a nice spaghetti inside the box, and the box open. So you need to make things simple. This one is Mobily in Saudi Arabia, and I think that I can say that. So that one is not the worst that you can see in Riyadh or in Jeddah. So, if you build a network just with the purpose of making bricolage and making things, your own way, this is what you get. So you need to make things simple. And after 16, 17 years of deployment in Europe, we know how to make things simple. Your contractors know how to make things simple. Skill concentration, this could be the UK. Okay, so in the UK, the big incumbent, so the operator, is using a pre-connectorized solution where they don't need to splice in those terminals. The guy just go there, put the terminal, and pull the cable, and go to a splice in a splice closure 50 meters far from there. It's not only Comscope, other suppliers supply those terminals. But that is a pre-connectorized terminal. Openreach is deploying 3.7 million homes a year. How can they go so fast? They can go so fast in part because they use a lot of pre-connectorization. They use pre-connectorization in the outside plant. They use pre-connectorization in the inside plant, in the ODFs. So the ODFs are also pre-connectorized. Okay? Even in greenfield, they go to the extreme. And they pre-connectorize that terminal, but also the tail of that terminal. So, it's really almost a plug-and-play network where they minimize the splicing. This is a common problem here in Germany, not only in Germany, in the DACH region, in the Benelux. Until last year, probably it was even more serious because there were not many alternatives. And the big problem is that when you pass homes, you need to connect homes. Because in Germany, it's very difficult to put handholds in the public domain. You cannot put handholds in the public domain. In the UK, when you make micro-trenching, they put what they call a Toby box. And that Toby box is in the public domain, in the paceway. So they don't need to connect Mr. Smith if he doesn't want to connect. They just put a Toby box in the paceway, and they leave the microduct there. Here in Germany and in other countries, that is not possible. And that's a big problem. So again, we need to make things simple. There are ways to go around that. But what is very, very expensive is that you connect every single home, in the village that you pass, because that is extremely expensive. I wanted to bring you, this is the case of a big customer. Now it's probably 600,000 homes, so it's a very big customer. And this guy is just by going from a mid-span solution where they needed to splice in every box to a pre-connectorized solution, they were saving 170 euros in manpower in every pole. In every pole, 170 euros. So this is just to give you an example that this is real life. The type of products, same thing. I told you the examples in the Middle East. You cannot put boxes that you need to open and that's so fragile. So the most important thing is that in the best case, you don't need to open boxes. But if you need to open boxes, you need to make sure the boxes are closed. And there are mechanisms for that, okay? Okay, so these are clear, another examples. 10% of the boxes in a big, is not Europe, it's Middle East, that in that operator, the boxes had to be replaced after a few months. Okay, I was even with the crews. In theory, they should have minus 25 dBm in that box. In most of the cases, that was not the case. It was in the middle of the desert with the dust caps taken, So, you know, it was a very poor quality network. So you cannot afford that. The picture in the center is not my number. It's a French public document that states that 30% of the terminals installed underground in France, they are leaking. So they are failing. So water is failing. Water is entering the closures, and the closures are failing. And why is that? Because you need to splice every drop. When you connect Mr. Chauvin or Monsieur Chauvin in France, you need to open a box and make a splice and close the box for every single customer. So what happens is that over time, many of these boxes, they are not properly closed, or they are not even closed. In France, in Normandy, imagine, they don't have water there. So, yeah, the one at the bottom, this is a customer that allowed me to show this. I cannot say the name, but this customer has a pre-connectorized network. Again, pre-connectorized is not CommScope. Many suppliers, all the suppliers you see here, they make pre-connectorized solutions. So we are all carpenters. And in this case, the network, you can see it has a reliability of 5 nines. The labor shortage is a problem. I mentioned that a bit in the beginning, but you can imagine, I'm working now in the Middle East and also in a bit in Africa. A few months ago, you know, for a network in the north of Africa, the price per splice was $30. So I was saying, hey, if CommScope don't want me anymore, maybe, you know, we should go and do some splicing there, $30. But also, if you talk about the UK, if you need to make one of Adrian's cable 288 fibers, they are paying you every single fiber at £16, even a 288 fiber cable. So, you know, for one day, it's good money. So the labor shortage is very important, and there is not enough trained people. So in the big deployments, like now Belgium, like Germany, the UK is going to come back. In these deployments, the assuring the specialized people is very important. This is the cost, real cost, in the UK to just make a terminal for 12 homes. Okay? So imagine, for 12 homes, to pass the homes, not to connect the homes, but to pass the homes, I need to spend 500 euros. Imagine, So it's extremely expensive to go that way. So you need to go around that. Yeah, my last presentation is a bit also the network optimization. You know, when I'm having chats with new customers, probably I still keep a job because if there are 40 networks in Europe, every network is different. And every network is different because the demography in each country is different. The infrastructure that you can use in every country is different. The business case of the operator is different. So every network needs to be different. One example, taps. Now some countries are going rural, like the UK, like Ireland, like my home country, Spain. We are going rural. Some people is still doing rural with centralized topologies. And honestly, I don't try to be arrogant, but this is consuming like 30 times more fiber than if you go with other solutions, okay? We in CommScope sell fiber, but you know, we don't like to cheat people. So you can go with other topologies. For instance, taps. Taps are extremely popular in Latin America or in Asia, but they are not popular in Europe. Until now, nobody told me why. I only have 2 projects of taps. Till now, nobody told me why. Taps are very inexpensive. They are rigid. It's a rigid topology, okay? You don't have a fiber-rich network in all areas, but it's very inexpensive compared to centralized or distributed topologies, particularly if you go to rural areas. Because when you go to rural areas, you have very long distances, so a lot of cable. So if that cable can be thinner with 12 fibers instead of 48 fibers or 144 fibers, that makes a difference. It's not only the cable, it's the closures that you have around that. It's the digging and the cabling that you need to make. It's the cabinets or the not use of cabinets. So the topology depends on the demography very much, and you cannot put the same network in Scotland that you put in Bayern, even if they are rural areas. So there are many aspects to consider, and the network design is key. Okay, yeah, the other aspects, I think that my colleagues talk a lot. Now we are all in the race for sustainability. This sustainability means thinner cables, eco-packaging. So yeah, I think that's a bit the lessons that not lessons, I don't like to say lessons, but over the years, a few things that we learned that I wanted to share today. Thank you.
Just on time. Thank you very much. So I hope that on your side, you got some insight on how innovation is there to help you to solve your field issues. Simpler, more flexible, faster, less expensive. But I hope that you were convinced, if not already before, that you can also now, and you should now, you shall even, integrate sustainability in innovation, and then to demonstrate how the new solutions that are implemented on the field are more future-oriented. I would like to thank the speaker for their time and the quality of the presentation. So please make a short and applaud them for this presentation. Thank you.